Basically, they're saying it takes Joe, 2 minutes to walk one block. They're saying he starts on the 3rd Street and he is walking towards the 50th Street. So they just want to know, based on this time chart, where he will be. How far will he have made it? So fill the chart below showing what street he is at depending on how long he has walked. So what do you guys think? If he is starting at the 3rd Street, we know it takes him 2 minutes to walk a block. So at the end of these 2 minutes, where is he going to be?
4th.
Yeah, 4th. So using that same idea, go ahead, fill in your table, and let me see what numbers you fill in those other spots. And then send me your answers through chat once you are done completing your table. Okay, so let's see, at 2 minutes, he's on street number 4. At 4 minutes, that's 6. At 6 minutes, that's 8. 8 to 10, 10 to 12, 12 to 14. So let me see what the rest of you are coming up with. Okay, so Brandy, you're saying that's not the answer then? Okay. Yeah, because if you guys had a chance to see Brandy's previous answer, you would have seen that, she actually moved him 2 blocks for every 2 minutes, right? But the speed he is walking at is 2 minutes for 1 block. So every 2-minute increment you see here, yeah, he's actually only moving by 1 block. So he has only made it to the 9th Street by the time 12 minutes have passed. Yeah, very nice. And that's the answer what all of you guys came up with. So that was, let me see, Arthur, Maya, John, Mikhail, Elena, Angelo. Yeah, so just kind of be careful, because I think it's very easy to kind of do that 2-to-2 ratio, but it's only 2-to-1 as terms of how fast he walks. So basically they're saying, graph this information with the time on the independent axis or the x-axis and street on the y-axis. So, obviously, since we are doing this electronically, we will not be able to do a graph. If you have a graphing paper easily available or just a notebook, you can try and see what the graph will look like, because some of these questions are actually going to be based on, what kind of graph you end up coming up with. So they're talking about, how you should obviously notice that it's a straight line. And they're asking you to write the equation of this line, you know, in the form of y equals mx plus b, where of course m would be the slope, b would be the intercept. So they're actually asking us, what is the y-intercept of your on your graph? Where does the line cross the y-axis? And you know, that gives us the b value. So if you look at the table we have over here, and this is actually a very badly designed graph because this is our street number here. So at 0, 3, you know, we would be somewhere over here. Then you've got 2, 4, and this guy will actually be 5. So 2, 4 will be somewhere over here. And so we have tried doing this example in class, and usually our graph comes out looking pretty interesting just because the grid is so badly designed on this. But hopefully once you get those first few points, it should kind of help us come up with an idea of what a graph for this guy would end up looking like. Hopefully something like this. And yeah, so that's the reason why usually these graphs end up looking pretty funky, because they've given us such a terrible grid to work with. So I always, you know, prefer students having graphed this on paper instead of on the handout, because it works out a lot better. So just by looking at this rough sketch over here, where would you say is the y-intercept for this line?
Zero, 3.
Yeah, very nice. Because that is basically our starting point, right? That's where Joe ended up starting at. So 0, 3 actually tells us that our b value is going to be at positive 3. Now the next part they're actually working us through is coming up with the slope for this line. So we know that's the ratio of rise over run. So they're basically asking you what variable is rising or going up and down. And that is, of course, in terms of, is it the street or the time? So what variable is rising in this?
Street.
Yeah, very nice, because that's our y value in this graph. So the street is rising. So of course that means the time is going to be the variable that is moving left or right, or, you know, the run coordinate. So then they're saying pick 2 data points. You know, how many blocks does Joe travel between those 2 points? So you can actually do that instead of the graph from your table. Just pick any 2 of these ordered pairs. And, you know, basically based on that, we can calculate our slope like we have normally done. So if you just start with those first 2 ordered pairs, you know, we can use 0, 3, and 2, 4, or any of the other ones, and then basically you can see how many blocks does Joe travel between those 2 times, and you will see he has traveled 1 block, right? Because he's only gone from block number 3 or street number 3 to street number 4. How long does it take him to travel that distance? And again, we actually had that information because they gave it to us at the very beginning of this assignment. They told us in 2 minutes he is walking 1 block. Now the idea is, how are you going to put this in the ratio to make it look like a slope?
So we know that rise is the street, and like the run would be the time. So you just put it rise over run. So you put 1 over 2.
Very nice. Yeah, very good. So you're only traveling 1 block in 2 minutes. So that is basically your slope. And then using this idea of, you know, the starting point was at the 3rd street, his rate of change or how fast he's walking is basically this is going to be in terms of, and if you actually look at this with the units, we're basically saying he is walking 1 block in 2 minutes. So if you look at this as a rate, we're basically saying his rate is half a block per minute, which makes sense. So he's got 1/2 x plus 3, because that 3 was his starting point. So now they are saying the street number Joe is basically going to be the function of the time it takes him to walk. So the x here actually represents your time, and the y will represent which street we would expect him to be at. So they are saying write your equation in the form j of x equals mx plus b. So honestly, all you are doing is replacing that y with j of x, and of course we're using j because we're calling him Joe. So as a function, you're just rewriting this as j of x equals 1/2 x plus 3. So the idea here is we were given the speed at which he's walking. We were able to come up with this table, fill it up with that information. Based on the table, we were able to come up with its graph. And then based on the graph and those ordered pairs, we now have an equation. So you can see just the flow of information, how it works. So now they want to know, what street will Joe be at after he has walked for 20 minutes? So they're saying you can do this numerically, graphically, or analytically. So let's start with numerically. What are we going to have?
1/2 times 20 plus 3.
Yeah, very good. You're just using this equation or function. And what do we come up with as our answer?
13.
Yeah, so he should be at the 13th street. Now, I'm not sure how accurate my graph is, but at 20 minutes, I don't think I'm quite there, because this would be at 12.5, which is halfway. So at 13 would have been somewhere over here. So yeah, you can see the graph is definitely not accurate. And that's one problem. And you will probably hear me complain about this as we walk through this assignment, but I absolutely hate this grid. So graphically will not work out if you're using my graph, okay? Analytically, how would you do this? Basically, think about it as his speed of walking is half a block every minute, right? So if he's walked for 20 minutes, in those 20 minutes, forget where he started at. How many blocks would he have walked in 20 minutes? Half that time, right? So it would be 20, and half of that would be 10. So we know in 20 minutes, he's only walking 10 blocks. And if he started at the 13th street, then, obviously he's ending up at the 3rd to the 13th street. So that's basically how I look at it, in terms of analytically. Okay, so now working in the other direction. Now, how long will it take him to get to the 20th street? So now how would you calculate that?
I would say 20 equals mx plus b.
Very nice. Yeah, so you're actually given the y value and you're working backwards to find the x. Very nice. So what do we think that will come out to be? So hold off on your answers just yet. Let's give everybody a chance to answer, and then when I ask you, you can send it through chat. Okay, go ahead, send your answers in. Alrighty, so looks like you guys are coming up with 34 minutes. Yeah, because what's going to happen, if you're again just looking at this as solving an equation, of course, we would start by subtracting that 3, moving it to the other side. So you would end up getting 17. And then to get the x by itself, we would multiply both sides by 2. So then you would end up multiplying this by 2, which would end up giving you 34 minutes. Alrighty, very good. Let's see what you guys come up with for number 13. Where is he going to be after 15 minutes? Okay, go ahead, send your answers in, guys. Let me see. Okay, so think about this. Your answer is not wrong, but in terms of the context we are talking, when you say 10.5 block or 10.5, what exactly does that mean? Because obviously there's a street called 10.5, right? Or at least we hope there's not a street named 10.5. So how would you describe that if you had to?
He's on the 10th Street, but halfway to the 11th Street.
Very nice. Yeah, that's kind of what I was hoping for. So obviously when you just plug this into your formula, you will get your street number, or at least what we hope as a street number, as 10.5. But that's exactly what it is. Very nice, Braden. So it's halfway between the 10th and the 11th Street is where we will find him. Alrighty. So now we're bringing in another individual, and now we're saying Miguel walks at the same pace as Joe, but he is starting at the 7th Street, so keeping the same pace. So based on what we did for Joe's example, what do you think the equation for Miguel's example will end up looking like? So again, I'll give you guys a second to think about this, and then when I ask you to, you can send your answers through chat. So let's see what Miguel's equation ends up looking like. Okay, go ahead, send it in. Yeah, because really the only thing that has changed is where he started out at, right? They're telling us he's keeping the same pace, which means he is obviously also doing 1 block in 2 minutes. So that slope obviously will not change. The only place that has changed is basically what we're calling as the y-intercept, his starting point, which is of course going to be at street 7. Yeah, very nice. All righty, good job, guys. So they want to know what is the same and what is different about Joe and Miguel's equation. So same, of course, is the slope. So they have the same slope, which in this case ends up becoming the same pace. And they will have different starting points. So that will be different y-intercepts. I think they're actually asking us to graph Miguel with Joe. I will make an attempt, but obviously you can see my graphs are not coming out to be accurate because this would be the starting point at 7 and keeping that same slope. But again, I know my slope was incorrect. It's probably not going to work. But the idea you should actually have here is since they have the same slope, we know having the same slope means the two lines will basically be parallel, right? Their starting points will be different, but the two lines should be parallel. And obviously we're not noticing that with these graphs here, but this one here is for Joe. This one here, let's say, is for Miguel. Okay, so now we're getting into a third character here. So this one is talking about Susie rides her bike in the opposite direction, starting at the 30th Street. She rides 5 blocks in 2 minutes. So again, same thing, they're asking us to complete this chart over here. So again, I'll give you guys a minute to work on it. Send me your answers to chat. Let's give everybody a chance to work on it. So don't send your answers till I ask you to. Okay, go ahead, send your answers in, guys. Okay, so let's see, you've got 2, 35, 4, 40, 45, 50, 55, 60, 25, 20, 15, 10, 5, 0, 30, 25, 20, 15, 10, 0. Yeah, Arthur, you went in the opposite direction, right? You were climbing up, but since she's in the opposite direction from the others, you're coming backwards. All righty, good job, guys. Okay, so John, looks like you're actually ending with 1. And why did you end with 1 when everyone else you went down by 5?
Well, I just assumed that she was at the beginning of First Street, so technically it was 5 blocks. I don't know.
Okay.
Everyone 1.
And Katie, looks like you also actually climbed up instead of coming down. Angelo, you actually also did the same thing. And that's the crucial thing. And that's actually a mistake that does happen because we're always thinking, we're going up in the street number. But since they're specifically telling us that she's riding her bike in the opposite direction. That means with every 2 minutes, you are traveling 5 blocks, but you're headed, in the count down. So yeah, technically you end up at 0, but we had this discussion in our class. So if you just think about the way streets are numbered, what would we technically think of as street 0?
Would that just be home?
Just be home. I've actually had some students say you could think of it as, kind of like Main Street, because usually you will see the numbers kind of counting away from Main Street. So you can think of that. Maybe you've reached the center of the city, or, downtown, or wherever you are at. So maybe that's your starting point. So yeah, it just actually obviously would depend on, a particular city and how they number theirs, but we will just leave it at street 0 for now. Since we have to go down by 5 blocks. So what happened, John, with your answer, since you went from 5 to 1, technically you only traveled 4 blocks, right? Because you went from the 5th street to the 1st street. So to make it that 5 blocks, you do have to go down to 0. Okay. So the next question here, of course, is they're talking about graphing. So we're not going to worry about that for a second here. So they want to know what the equation for Susie will end up looking like. So while you guys are working on that, I'm going to try coming up with some form of this graph here. So let's see, there's some other happy number in here. Oops. This will be Susie's graph. All right, folks, let me see what you've come up with. Negative 5/2 x plus 30. Maya, you've got 2.5 x minus 5, negative 2/5 x plus 30. Oh, okay, wrong order. Maya, I'm actually a little bit curious about your equation over here. The 2.5, I can kind of see would become 5/2, but then what's with the minus 5? Okay, Elena, you've got 5/2 x minus 7. Oh, okay, Maya got it. Negative 5/2 x plus 30, negative 5/2 x plus 30, negative 5/2 x. John, you've got 5/2 x plus 30. Okay, so it looks like we're either putting the negative sign on the 5/2, or some of you actually have a negative sign on the 30. So as you would have seen, or if you have not noticed, let me show you kind of what the graph looks like for Susie. So you can see, since she is going in the opposite direction, we do expect her graph to not be in the same formation as Miguel and Joe. So since you can see that she was going in the opposite direction, so that technically does make her slope a negative slope, because she's going down in her street numbers as she moves in the opposite direction. So the negative actually has to go on the slope, not on the street number 30. So in this case, her rate is in 2 minutes, she is doing 5 blocks, but since she is going in the opposite direction, we make that a negative slope. And again, her starting point was 30, because you know what happens is if you leave the 5/2 positive and make the 30 negative, if we start with that x as being 0, you know, you would have 5/2 times 0 minus 30, which would end up giving us 0 minus 30, which would technically give us negative 30 as the answer. And you know, our street number cannot be a negative number. So that's the reason why we don't really want to put the negative on the 30. So the street number will be positive, but it's actually the slope that will end up becoming negative. And then when you change those signs, you will of course see that ends up giving us a positive 30 as our street number. Okay, so again, they're asking us to talk about what is different about Susie's equation compared to Joe and Miguel's. So what differences are you noticing between Susie's equation here and then the equations we had for Miguel, which was 1/2 x plus 7, and of course Joe was 1/2 x plus 3.
Slope and starting point.
Yeah, both of them are different. Very nice. Okay, so for the next question, they are asking us when will, or basically at what time will Susie be at the same place as Joe? So I'm going to let you guys think about that and let me see what you are able to come up with. So what are you thinking for when Susie and Joe will be at the same place? Okay, so would somebody walk me through the process of how you are coming up with your answer? So Arthur, you came up with 9 minutes. Mikhail, you've got 9 and 7.5. Maya, you're saying 8. Caitlin, you've got 9.
I set the equations equal to each other,
Okay.
and then I was just about to go through and double check to make sure it comes out right.
Okay, alrighty. And looks like Braden, you also came up with 9 minutes. So Maya, looks like right now you have the different answer. So do you want to walk me through what you did?
Because we're at what? Okay. So on minute 8 for Susie, she'd be at the 10th Street. And at minute 14 for Joe, he would be at the 10th Street. So I just kind of looked at my charts.
I see. Okay. And then Arthur, you were talking about setting the two equations equal to each other, because by setting it equal to each other, you're basically figuring out, that would be the same place they are at. So we've got Susie as -5/2 x plus 30, and Joe was +1/2 x plus 3. So if you set those two equations equal to each other, let's see, I would basically go ahead and subtract 3 on both sides. Maybe we'll do that over here. -5/2 x plus 30, and that is equal to 1/2 x plus 3. So I don't know, subtract 3 from both sides. You would end up getting 27, 1/2 x on the right, and still the 5/2 x over here. Since we moved the 27, you can go ahead and move the 5/2 to the other side. And that would end up giving us 27 equals 5/2 added with 1/2. You can see they already have a common denominator. So that would just give you 6/2, which would of course reduce down to 3x. So when you divide both sides by 3, we would of course end up getting 3 goes into 27 9 times. So this is actually how, and I am imagining, is that what most of you did who came up with the 9-minute as your answer?
I just took the graph and found where they intercepted.
Yeah, and that definitely works if you have a graph that is, accurately drawn over here. So that would basically be where the two graphs would intersect, and you can see we should have at 9 minutes, and then at 9 minutes they would be at what, between 7 and 8, and I think that's why you had 7.5, I think, on your answer, Mikkel, I believe. Which again, my graph is not really very accurate, especially Joe's line is not graphed accurately. So yeah, the graph would definitely help you out with that. And so if you do have a decent graph, that should help you get that. So you should have 9 minutes. Maya, does that kind of help you out with your answer? Yeah. So they are saying evaluate S of 7 and J of 7. What do they represent? So what would you say about this?
You're just going to plug the 7 in for x in the Susie equation or the Jason equation. Or
Okay.
is that what it was?
Joe, that's fine.
Joe, sorry.
Somebody with J.
Yeah.
And what would we end up getting for that? So what did you guys get for S of 7 and J of 7?
For J of 7, I got 6.5, and for S of 7, I got 12.5.
12.5, okay. So of course, that means at 7 minutes where they were, right? When they're talking about what does this represent. So at after 7 minutes have passed, basically Jason is what, between the 6th and the 7th Street, but Susie is going to be between 12th Street and what? Or no, yeah, because you are at 12.5.
Between 12th and 13th Street.
It'd be 11th, wouldn't it?
Yeah, and that's the crucial part because she is coming in the opposite direction. So she is actually between the 11th and the 12th streets, and I want to call him Jason because you called him Jason. Joe is between the 6th and the 7th streets. Alrighty. So what do you think when we subtract these two numbers, what will you get as your answer, and what will that represent? So what did you get as the answer for S of 7 minus J of 7?
You'd get 6,
And what
and
is
it'd represent the distance between them.
very nice. Yeah. So that actually gives you how far apart they are at minute 7, basically. Okay. So they're actually saying, you know, if we always wanted to kind of calculate what the difference between Susie and Joe's location would be, you can actually take the two functions and subtract them together, which is what we had done with the operation of function. So, you know, this is where we would take Susie's equation and we would subtract that from Joe's equation. So when you did that, you would basically end up with, let's see, we are doing -5/2 minus 1/2. So that would actually be -6/2 x. And then we would be doing +30 minus -3. So you would actually be, and we know they're 27 blocks apart. So you would actually have an equation of -3x plus 27 if you were to do a subtraction, because remember, you always distribute that negative sign inside your parentheses. So you are subtracting 1/2 from -5/2, you're subtracting 3 from 20. And we know, like I said, she's at the 30th street, he's starting at the 3rd street. So that is a difference of 27 blocks. And then in their pace also, it's a difference of 3 blocks. No, sorry, because let's see, he is doing 1 block in 2 minutes and she is doing 5 blocks in 2 minutes. Yeah, so if you look at the difference in their pace, you will get a -3x with that. So if we had this, would we get the same answer if you just plugged in the 7 minutes as we did over here in number 23? So if you just took that -3x plus 27 and you plugged in 7 minutes, would you still have the same answer?
Yes.
Yeah, because what will we get for -3 times 7? Wouldn't we get -21? And then when you add -21 with +27, you are still going to see that difference of, you know, those two folks being 6 blocks away at each other. And, you know, you can do the same thing with obviously Miguel's example also. So now the idea is they want to know, how could this function help you answer number 21 in a different way? And that's this -3x plus 27 that we came up with. What would we have done to come up with the answer for number 21, where they were asking us, Susie and Joe would be in the same at what time would they be in the same place? So if you had this equation, negative 3x plus 27, how could you have worked with this equation to help you answer the question in number 21?
You set that equation equal to 0?
Yeah, because the distance would be 0, right? Because at this point, if they are in the same location, then that means your distance is 0. And then if you were to solve this for x, you would see we would exactly end up with 9 minutes for the x value. And you can just see that very quickly as you solve this. We end up getting x equals 9. And that means at 9 minutes, they would both end up in the same location. So just different ways of how you can manipulate your functions and still come up with the same answers as we did by using 2 different functions. Alrighty, any questions on this one, guys? So just a very simple example, but again, just to get you comfortable with graphing, the function notation, and how all of those different values can correlate with each other. All right, guys, so for Monday, we are looking at chapter 3 exam. I will see you in the lab afterwards, and then a week from today, we'll start chapter 4. Okay? All right, everybody, be careful. Have a great weekend. Stay safe, and I will see you on Monday morning. Bye,
All right, see you
guys.
Monday.
Be careful. Thank you.